Welcome back. We're now on chapter 14, where we're diving into layer 2 and wireless security. In this one, we'll look at common network attacks and how to protect your network using real-world security techniques. Let's get into it. Network security should be second nature for any network engineer. Understanding how attackers exploit layer 2 vulnerabilities is essential to protecting an organization's infrastructure. In this chapter, you will learn how to apply a defense-in-depth approach to secure both users and devices. You'll explore common layer 2 attacks, how they work, and how to prevent and mitigate them using proper security controls. Topics covered: types of layer 2 attacks, protecting against layer 2 threats, and wireless network security. As a network engineer, your role goes beyond designing and implementing networks. You are also responsible for securing them. With constantly evolving threats, attackers are developing new tools and techniques to exploit network vulnerabilities. Modern cyber attacks are no longer just for curiosity. Many are financially driven, such as ransomware, which encrypts data and demands payment for its release. At the same time, there is a growing shortage of cybersecurity professionals to combat these threats. This makes network engineers a critical part of an organization's security. By understanding common attack methods and applying a defense-in-depth approach, you can significantly reduce the risk of successful attacks. Cyber attacks are increasingly common, affecting organizations of all sizes. As John Chambers once said, there are two types of companies: those who have been hacked and those who don't yet know they have been hacked. Many organizations underestimate their risk, believing they are fully secure and not valuable targets. In reality, no network is 100% secure, and vulnerabilities always exist, both known and unknown. As security professionals, our challenge is to identify and mitigate these weaknesses before attackers exploit them. Every system contains valuable data. Devices such as smartphones, servers, routers, and switches store sensitive information including user data and activity logs, MAC and IP address tables, credentials and access configurations, network traffic, and system logs. To attackers, this data is highly valuable. Organizations are commonly targeted by data breaches, which is unauthorized access and data theft, malware, malicious software that compromises systems, and DDoS attacks, overwhelming services to cause disruption. Modern attacks are often financially motivated. Attackers aim to steal, sell, or exploit data for profit. Malware is frequently used to compromise systems. A major example is ransomware, which encrypts data and demands payment for its release. One well-known case is WannaCry, which exploited a vulnerability in Microsoft Windows SMB version 1. Once infected, systems were locked and victims were asked to pay in cryptocurrency. Not all attacks aim to steal data. Some focus on disruption. Distributed denial of service attacks flood systems with traffic from multiple sources, often using botnets, making services like websites unavailable. These attacks are sometimes used by hacktivists as a form of protest. Key takeaway: preventing all attacks is extremely difficult. The goal is to reduce risk by understanding threats and applying layered security strategies. Relying on a single layer of security is no longer effective against modern cyber threats. Solutions like firewalls or antivirus alone cannot fully protect an organization. Defense in depth is a multi-layered security approach that protects systems, users, and data by combining multiple security controls. If one layer fails, others are still in place to stop or reduce the impact of an attack. A strong DID strategy includes firewalls, anti-malware, endpoint protection, intrusion prevention systems, email and web security filtering, and secure remote access (VPNs). A next-generation firewall enhances protection with stateful packet inspection, application awareness and control, and integrated threat prevention, IPS and malware protection. Remote workers introduce additional risk. Using a VPN ensures encrypted communication and secure access over untrusted networks. Endpoints, like PCs, laptops, servers, IP phones, are common attack targets. Stronger protection requires anti-malware, host-based firewalls, and intrusion detection prevention. A layered approach improves detection and reduces risk. Email is a major attack vector, especially for phishing, spear phishing, and malware delivery. The email security appliance provides threat detection and blocking, malicious link filtering, email encryption, and data loss prevention. It also scans outbound emails to prevent malware spread and data leakage. Web traffic is another common attack path. The web security appliance provides URL filtering and malware scanning, web access control, and blocking of unsafe or untrusted sites. All web traffic is inspected before reaching the internet. Key takeaway: a layered security approach significantly reduces risk by combining multiple defenses across the network, endpoints, and users. Most security solutions operate at layer 3 to 7, but layer 2 attacks can bypass these protections entirely. If layer 2 is compromised, attackers can intercept traffic before higher layer security even applies. Cisco switches include built-in features to detect and mitigate layer 2 attacks, making it essential for network engineers to understand these threats. Switches store MAC addresses in a CAM table to forward frames efficiently. So attackers flood switch with fake MAC addresses, CAM table fills up, switch fails open, and switch begins broadcasting all traffic, like a hub. The result? Attacker can capture network traffic. So VLAN attacks. VLAN hop-in exploits default dynamic trunking protocol. Attacker forms an unauthorized trunk and gains access to multiple VLANs. Then we have VLAN double tagging. Attacker inserts 2 VLAN tags. First switch trips outer tag and forwards frame. Second switch processes inner tag and sends to target VLAN. The result? Unauthorized access to restricted VLANs. To prevent this, set ports to access mode, disable DTP, manually configure trunks, and avoid using VLAN 1 as native VLAN. DHCP attacks. DHCP starvation floods DHCP server with fake requests and exhausts IP pool, DOS for clients. DHCP spoofing. Attacker sets up rogue DHCP server, provides fake gateway, fake DNS, and invalid IP configs. The results? Traffic interception or network disruption. ARP attacks, like spoofing, poisoning. ARP maps IP, MAC, but has no security. The attacker sends fake ARP replies, and devices update ARP tables with attacker's MAC. The result? Man in the middle. Traffic interception and modification. Spanning tree attacks. STP elects a root bridge to control traffic flow. The attacker sends superior BPDUs and becomes root bridge. The result? Controls traffic flow and enables man-in-the-middle attacks. You can prevent this. Enable BPDU guard and use port fast on access ports. CDP LLDP attacks. CDP LLDP shared device info. The risk: information leakage, network mapping by attackers, and injection of fake discovery data. Prevention: disable globally. No CD run, no LLDP run. Enable only where required. Key takeaway: layer 2 attacks are dangerous because they operate below traditional security controls, enable sniffing, man in the middle, and network disruption. Security layer 2 is critical to maintaining overall network security. Not all cyber threats come from the internet. Many originate inside the network, such as unauthorized devices being connected, misconfigured equipment, and malicious insiders. As a network engineer, your role is not just connectivity, but also securing the network at every layer, especially layer 2. Unused switch ports are a major security risk. They act like open doors into your network. Best practice: disable all unused ports and only enable required interfaces. Port security limits which devices can connect to a switch port. It helps prevent unauthorized access, CAM table overflow attacks, and MAC flooding. Basic configuration: interface FA0/1, switch port mode access, switch port security, and no shutdown. Key settings: limit MAC addresses. Default equals 1. Switch port security maximum 2. Static MAC address, only allow a specific device. Switch port security MAC address. And sticky MAC, learn and save MAC addresses automatically. Switch port security MAC address sticky. Remember to save config. Copy, running config, startup config. Violation modes: when an unknown MAC appears. Shutdown default, port goes into error disabled state. Restrict, drops traffic plus logs violation. And protect, drops traffic silently. Switch port security violation restrict. And agent is optional, automatically remove old MAC addresses. Switch port security agent time 5. Switch port security agent type inactivity. And the verification commands: show port security interface FA0/1, show port security, and show MAC address table. The key takeaway: port security is a simple but powerful layer 2 defense that controls device access, reduces attack surface, and prevents common layer 2 attacks. DHCP Snooping is a layer 2 security feature on Cisco switches used to prevent rogue DHCP servers and DHCP based attacks. Instead of relying on MAC addresses, it works by classifying ports as trusted or untrusted and controlling which DHCP messages are allowed. How it works: all ports are untrusted by default. Only trusted ports can send DHCP offer and DHCP acknowledgement. If an untrusted port sends these, violation occurs. Trusted ports connected to legitimate DHCP servers and uplink trunk links. Untrusted ports, access ports, end devices, where attackers may connect rogue DHCP servers. DHCP Snooping binding table. When enabled, the switch builds a binding table that maps MAC address, IP address, VLAN, and interface. This helps validate legitimate clients and detect spoofing. Key features: filters DHCP messages, blocks rogue DHCP servers, and rate limits DHCP traffic. Prevents starvation attacks. The configuration steps: Step 1. Enable DHCP Snooping with IP DHCP Snooping. 2. Specify VLANs: IP DHCP Snooping VLAN 5, 15, 20, 22. Configure trusted ports, interface geo/1, then IP DHCP Snooping trust. And step 4. Apply rate limiting: untrusted ports, interface geo/2, IP DHCP Snooping limit rate 10. Key takeaway: DHCP Snooping protects your network by blocking rogue DHCP servers, preventing DHCP starvation attacks, and ensuring only trusted devices assign IP addresses. Dynamic ARP Inspection is a layer 2 security feature used to prevent ARP spoofing and man-in-the-middle attacks. It ensures that only valid ARP requests and replies are allowed on the network. How it works: DAI works by intercepting ARP messages on untrusted ports, validating IP to MAC mappings using the DHCP Snooping binding table, dropping invalid ARP packets, logging violations, and disabling ports if needed. An important requirement: DAI requires DHCP Snooping, uses the binding table to verify legitimate devices. Without DHCP Snooping, DAI cannot validate ARP messages. Trusted vs untrusted ports. Trusted ports: trunk links, uplinks to routers, switches. Untrusted ports: access ports, end devices. Best practice: all access ports equals untrusted, only infrastructure links equals trusted. DAI prevents ARP spoofing, ARP poisoning, and man-in-the-middle attacks. Configuration steps: enable DHCP Snooping with IP DHCP Snooping, IP DHCP Snooping VLAN 10. Trust uplink interfaces, interface geo/1, IP DHCP Snooping trust, IP ARP Inspection trust. Enable DAI on VLAN, IP ARP Inspection VLAN 10. Optional validation checks: IP ARP Inspection validate, SRC MAC, DST MAC, IP. SRC MAC, this checks sender MAC. DST MAC checks target MAC, and IP validates IP addresses. Key takeaway: DAI protects your network by verifying ARP traffic, blocking spoofed packets, and preventing man-in-the-middle attacks. Combined with DHCP Snooping, it provides strong layer 2 security. Wireless LANs provide mobility and convenience, allowing users to connect from anywhere within range. However, this also introduces significant security risks, as attackers only need to be within signal range, not physically inside the building. Common wireless threats: eavesdropping, unauthorized access, denial of service, rogue access points, and evil twin attacks. Basic security controls: disable SSID broadcast, and MAC address filtering. MAC filtering can be bypassed, but still adds a layer of security. Authentication methods. 1. Open authentication. No password required. Used in public Wi-Fi. It's not secure. WPA3 improves this with OWE. 2. Pre-shared key. Requires a password to connect, and it's common in home small networks. Wireless security standards. WEP, outdated and insecure. WPA, improved over WEP but still weak. WPA2, AES, CCNP, current standard, strong encryption. And WPA3, SAE, most secure, protects against brute force attacks, and uses modern encryption. Authentication modes. Personal uses PSK, simple setup for home small office use, and enterprise uses AAA server, centralized authentication, more secure and scalable. Key takeaway: wireless networks are highly vulnerable because they are accessible over the air. To secure them, you must combine strong encryption, WPA2, WPA3, proper authentication, and additional controls, MAC filtering and monitoring. Summary. In this chapter, you learned the importance of using a defense-in-depth approach to strengthen network security through multiple layers of protection. You explored common layer 2 attacks and how attackers can exploit network vulnerabilities, as well as the impact these attacks can have on an enterprise environment. You also learned how to implement key layer 2 security controls on Cisco switches, such as port security, DHCP snooping, and DAI to prevent and mitigate attacks. Finally, you covered wireless security threats and the importance of using strong authentication and encryption methods to protect wireless networks. A secure network requires layered protection, proper configurations, and continuous awareness of threats. I hope you enjoyed this chapter. I'm CyberEd, and I will see you in the next one. Peace.